What if everything you knew, every living thing, simply vanished?
Life on Earth has faced 5 catastrophic events, eras defined not by discovery, but by loss.
These mass extinctions reshaped our planet, clearing the slate for new forms.
They were moments of immense destruction, but also of incredible evolutionary rebirth.
Join us as we journey through Earth's most devastating biological crises.
Our first journey takes us back 443 million years to the Ordovician-Silurian extinction.
During the Ordovician, marine life flourished. Trilobites, brachiopods, and early cephalopods dominated the oceans. The seas were warm, nutrient-rich, supporting complex ecosystems, a true paradise for marine invertebrates.
Gondwana drifted over the South Pole, triggering a massive glaciation.
Encased in the grip of the new ice, this ancient creature fights for its very existence.
Once vibrant, these reefs are now silent graveyards, choked by algae as the oxygen disappears. This Icehouse Earth event decimated marine life. Over 85% of species perished.
It was one of the largest biodiversity losses in Earth's history, a silent, chilling catastrophe.
The Ordovician-Silurian extinction teaches us the profound impact of global climate shifts. Life's resilience, however, meant new forms would eventually rise from the ashes.
Next, we move to the late Devonian, around 372 million years ago. A different kind of crisis unfolded.
The Devonian was an age of remarkable innovation. Plants began colonizing land, creating the first forests.
In the oceans, jawed fish diversified, and massive reef systems flourished, home to diverse marine life. Life was pushing boundaries, with incredible evolutionary leaps in both aquatic and terrestrial realms. But the very success of these land plants may have sown the seeds of destruction for marine life.
The deep root systems of these plants weathered rocks, releasing vast amounts of nutrients into the oceans.
This nutrient influx triggered massive algal blooms. When these blooms died, their decomposition consumed oxygen. This led to widespread anoxia, creating dead zones where most marine life could not survive.
The late Devonian extinction was a prolonged series of pulses, affecting primarily marine species.
It wiped out many reef builders and jawed fish, profoundly changing ocean ecosystems.
Now, prepare for the Great Dying, the Permian Triassic extinction, 252 million years ago.
This event was the most severe in Earth's history, wiping out 96% of all marine species.
And 70% of terrestrial vertebrate species. It was a global cataclysm, nearly ending multicellular life. Prime suspect: massive volcanic eruptions in the Siberian traps, lasting for millions of years. These eruptions released enormous quantities of greenhouse gases and aerosols into the atmosphere. This led to rapid global warming, ocean acidification, and widespread anoxia on land and sea.
Methane clathrates, triggered by warming, released further greenhouse gases, creating a runaway effect.
The oceans became hot, acidic, and oxygen depleted. Life simply couldn't cope.
On land, acid rain destroyed forests, and extreme temperatures pushed species to their physiological limits. Families, orders, entire classes of organisms vanished forever. It was truly the Great Dying.
The Permian Triassic extinction serves as a stark warning about unchecked environmental change. This Permian world, teeming with synapsids like this Gorgonopsian, was about to face its ultimate test.
The Permian period, a time of rich biodiversity,
saw complex terrestrial and marine ecosystems flourish.
These were vibrant, filled with creatures that had dominated for millions of years.
But then, 252 million years ago, came the Great Dying, the largest extinction event Earth has ever seen.
Primary suspect: massive volcanic eruptions in what is now Siberia.
The Siberian traps released unimaginable amounts of lava, gas, and ash for nearly 1 million years.
This carbon dioxide choked the atmosphere, triggering runaway global warming.
Terrestrial ecosystems turned to arid deserts. Life struggled to find water and shelter. The oceans acidified and lost their oxygen, creating vast, anoxic dead zones.
Marine life, unable to breathe or calcify shells, perished en masse. On land, 70% of vertebrate species vanished. In the seas, over 90% of all species were wiped out.
Earth became a silent, desolate planet, an empty canvas awaiting new life.
For millions of years, very little survived. The planet was profoundly scarred.
Among the few survivors was the hardy Lystrosaurus, a mammal-like reptile dominating the early Triassic.
Its resilience allowed it to thrive in the harsh, post-apocalyptic world.
But the emptiness left vast ecological niches. Evolution was ready to fill them.
From the survivors, new groups emerged. The archosaurs, ancestors of crocodiles and birds, began to diversify.
Small, bipedal forms like Euparkeria were among the first to explore new ecological roles.
From these unassuming beginnings, a new lineage would rise to dominate for the next 160 million years.
Dinosaurs, starting as small, agile predators, began their ascent.
They rapidly diversified into a multitude of forms, from herbivores to formidable carnivores.
The Triassic period became a time of recovery and innovation. But this new chapter also faced its own challenges.
As Pangaea began to split apart, massive volcanism struck again at the end of the Triassic.
The Central Atlantic Magmatic Province, or CAMP, released colossal amounts of greenhouse gases.
This triggered another pulse of global warming and ocean acidification, the end Triassic extinction.
While it cleared the stage for dinosaurs to truly dominate the Jurassic, it was another stark reminder.
Life's journey is punctuated by these cataclysms, each one reshaping Earth forever. And the dinosaurs, having survived, were about to embark on their golden age. But that, too, would end.
The story of Earth's extinctions is a testament to both destruction and the relentless power of life.